So let us discuss about this doubt. Okay, let me share my screen. Okay, is it visible now?
Sir,
Yes. So yesterday we got an equation like, if you look at your copy, you will find that sigma x is equal to I wrote E means Young's modulus, just this, into Young's modulus into strain. Because you know what you know, that Young's modulus is equal to E stress by strain. So from here I have written this. Okay, or I can write, here you put x in x direction, strain in x direction. So you can have equation like this. Okay, so this is clear. Now let me show you one thing. Suppose you have a rod. Suppose you have a rod like this. Okay, so let me compress it in x direction. So therefore reaction force will come in this direction. Why I have slashed this line? Because this is reaction force and this is the force applied by you. So what will happen to this shaft? It will, its length will be decreased, but its area will increase. Let me draw it in red color. Others has joined. Others, Gurung, we are discussing about your doubt. Okay, you listen carefully. So this Gurung, you have joined late. So I'll tell you, this is sigma x equal to Young's modulus into strain in x direction. That means you know that Young's modulus is stress by strain. So that formula I have written. Or you can write like this. Okay. Now suppose you have a shaft and that you have compressed it from x direction. So this is sigma x and this is reaction. So I have put the slash line. So if you compress this bar, so definitely what will happen? So definitely its area will increase. Is it not? Are you clear about that? Its area will increase, but its length will be decreased. So now
yes, sir.
the length is, suppose initial length, let me take suppose capital L. Now it is decreased by suppose delta L. Clear? But length is decreased. But initially suppose the area of cross section was your A. So after compression, it will increase A plus delta I. Delta I, sorry. So this thing, are you clear? Area will be increased, but length will be decreased. So now you see, if in x direction it is decreasing, but in y direction, this is your y axis. If you now take x and y axis, you will see that this is your x axis, this is your y axis. So in y direction it is increasing,
Increase.
but in x direction it is decreasing. That means both are opposite. If one increases, the other one will decrease. Okay, that is why we have written like
Sir, we cannot see.
Huh?
We cannot see your screen.
You cannot see?
Screen.
Wait, let me share once again. Wait a minute.
Problem is sir.
Now is it visible?
Zero.
Visible?
Visible, sir. Visible.
Okay. So shall I repeat this thing? You want me to repeat?
Yes, sir. If you could repeat it, it would be better.
Okay, then let us start from the beginning. So this is your stress, this is Young's modulus, this is your strain. Both are in x direction. So you know Young's modulus is equal to stress by strain. So from that I have written strain is equal to stress by Young's modulus. Okay. Now come to this figure. Suppose you have a shaft of length L, then you have compressed it with force with stress sigma x. Okay, from x direction. So there will be definitely a positive reaction from the negative x direction. So that will be reaction is indicated by slash line. Okay. So now if you compress it, so definitely it's a common idea that it will get shortened, and due to shortness, its length will be decreased. So initially, if it was L, now it will be L minus del L. And if initially in area was A, now it is increased. So that will be A plus delta A. So see, this is your y-axis, this is your x-axis. So in x direction it is decreased and in y direction it is increased. So one is opposite to other, right? If one increases, the other one will decrease. So if that thing happens, then we can write strain in y direction. Similarly, we can write strain in z direction is equal to your nu sigma x by E. Now, let me come to this point one more time. So, you know, Poisson's ratio nu is equal to your lateral strain by longitudinal strain. Now, look at here. This is what? This is your lateral strain, and this is what? This is your longitudinal strain. So, definitely, if you divide it with your longitudinal strain, definitely you will get your nu. Is it clear or not? That minus sign you forget about now. Is it clear?
Yes, sir.
So lateral strain by longitudinal strain. So this is your lateral strain. If I take this figure, if I consider this figure, then it will be your lateral strain. It will be your lateral strain only sigma x by E, which is equal to epsilon x. It is your longitudinal strain. So lateral strain by longitudinal strain will be your nu. Okay, clear?
Sir.
So lateral strain is your what? Sigma y, or you can write sigma z also, no problem. And it is your sigma x. So ultimately, what do you get? Now clear? So why negative? There is a negative sign. Why negative? Because lateral strain is always accompanied with longitudinal strains or vice versa. So if one is increases, the other will decrease. So definitely there will be a negative sign. Now is it clear or not, Gurung, and to everyone? Clear? Yes? Is it clear to you? If it is clear, then I'll go forward.
Okay, sir.
I can't hear you. Okay, let us assume you have understood. So that day we have written up to the generalized Hooke's law for isotropic linearly elastic materials for use in Cartesian coordinates can be written as follows. After that, you write the equations now. So the same equations only. So now you can comprise all strain in x direction as sigma x equal to epsilon x equal to sigma x by Young's modulus minus just you have got new sigma y by epsilon Young's modulus minus new sigma z by Young's modulus. Okay, and your shear strain is equal to shear strain denoted by gamma in xy plane is equal to shear stress by modulus of rigidity. Okay, so okay, here next similarly you will get sigma y is equal to gamma sigma x by e plus sigma y by e minus new sigma z by e, and shear strain in yz plane it will be tau yz by z. Okay, again sigma z minus new sigma x by e minus new sigma y by e plus sigma z by e, sigma z by e, and gamma zx is equal to tau zx by z. So put them, suppose equation number. So earlier you gave some equation numbers. No. So let us call this equation number. Hello. Anybody? What will be the number of this equation? What is this equation number? Because I have forgot earlier what up to what equation number I have put. Because this is continuation of the previous class. So what is the equation number of this? Okay, put some equation. Okay, suppose I have put 1. Suppose this is 1 for me. On simplification, we get, after simplification you will get sigma x is equal to lambda into epsilon x plus epsilon y plus epsilon z plus mu into epsilon x, and tau xy is equal to z into gamma xy. Similarly, sigma y you will get lambda into epsilon x plus epsilon y plus epsilon z plus mu into epsilon y and tau yz is equal to g into gamma yz, and sigma z is equal to lambda epsilon x plus epsilon y plus epsilon z plus mu epsilon z is equal to tau zx is equal to z gamma zx. Let me call this equation number 2. Let us call this equation number 2, where lambda and mu are the lamp parameters. Which are related to the Young's modulus E and Poisson's ratio nu as follows. So lambda is equal to mu into E by 1 plus mu into 1 minus 2 nu. This is one relation, and mu is equal to E by 1 plus mu. This is another relation. Done up till here. If the normal stresses are compressive, the signs of the corresponding terms change in equation one. So now don't confuse with the previous one. I was asking you about the question number. So 1 means So 1 means actually this. This is 1. Okay. So probably you have another equation number 1 in the last class that I don't remember now. But equation 1 means I have meant this particular equation, this set of equation. So remember that this equation for the normal string. Now take an example. A 50 cube of steel is subjected to a uniform pressure of 200 megapascal. Acting on all presses. Are you able to follow me? Hello?
Yes, sir.
Okay. Determine the change in dimension between two parallel faces in the cube. E is 200 gigapascal GPa and Poisson's ratio nu is equal to 0.25. Now come to the solution.
So the value of E is also
200 GPa, gigapascal,
okay.
200.
Okay.
Okay? The solution. So pressure is always a compressive stress actually. If you press something, that means actually compressive. Pressure is a compressive stress. Okay? So if you take compressive stress, so definitely your these equations 1, these equations, their sign will be changed because these are the equation for your tensile stress. But if it is compressive stress, then these signs, this will be negative, this will be positive. So negative will be positive, positive will be negative for compressive. This is for transverse, sorry, longitudinal or normal strain or tensile stress. Okay, so that thing I have mentioned here. If the normal stress are compressive, the signs of the corresponding terms change in equation 1 for the normal strain. Okay. So now, as we are encountered with problem with compressive stress, we have to change the sign. So ultimately, sigma x will be your epsilon x equal to sigma x by Young's modulus. Actually, we are following what? We are following equation 1. Let me write here. Equation 1. Refer to equation 1 for your reference. It is not necessary. Plus, the rest of the thing are similar. So now, what is sigma x? What is new that you can get from the question? So 200 megapascal, that is the stress uniformly, since it is told acting on all the faces. So pressure on all the faces will be 200 megapascal. So you write in place of sigma, you write 200 into 10 to the power 6 megapascal, no? And E is given as 200 GPa into 10 to the power 9 actually. Okay? So this is a Pascal, this is also Pascal. Plus nu is given as 0.25 into 200 same, because same pressure is acting on all the faces. So it will be here 200 into 10 to the power 9 Pascal plus what is this? This is E, huh? This is E. Okay. Again 0.25 into 200 into 10 to the power 6 by 200 into 10 to the power 9. Here Pascal, here Pascal. So all the Pascal will get cancelled. Okay. And this will get cancelled, and there will be 3, 200, 200. There will be 3 Pascal, Pascal 10 to the power 6, 200, 200. So there will be 3, 200, 200 Pascal, Pascal. So what remains ultimately? Here minus 200 into 10 to the power minus 3. Sorry, minus 10 to the power minus 3 plus 0.25 into 10 to the power minus 3. Here also 0.25 into 10 to the power minus 3. So ultimately we can multiply it by 2. So what you will get? This is nothing but your 0.001 plus 0.25 into 2, that is 0.5 into 10 to the power minus 3, or minus 0.001. So it will be ultimately 0.0005. So what you will get? Add it, sorry, subtract it. You will get, how much you will get? Minus 0.005. Ultimately you are getting 5 into 10 to the power minus 4. Fine. So that is your strain in x direction. So in the question it was asked that change in dimension. So change in dimension delta x equal to what? Strain into original length, because you know what is strain. It is the change in dimension by original dimension. Okay, so your change in dimension, let's say it is x, so this is actually change in dimension. Change in dimension, let's say delta x. So delta x equal to, from here you can write delta x by original length, suppose lx. So ultimately, so this is delta x. So delta x equal to epsilon into lx. I hope you understood. So 5 into 10 to the power minus 4, that sigma epsilon value into original length of the cube was given as 50 mm. Okay, so ultimately you will get 0.025 millimeter. So negative means contraction and positive means extension. Okay, similarly you can calculate, that is not necessary since it is a uniform. Similarly, delta x is equal to delta y is equal to delta z.